Hello everyone. Let's introduce this to you. Classification and building mode of civil buildings. Firstly, we will introduce the classification of buildings. We have already learned how to classify buildings earlier. What is the grading of buildings? What is the difference between the grading of buildings and the classification of buildings? To clarify this issue, let's take a look at these pictures. In the first picture, we saw various fruits. We can divide them into apples, oranges, bananas, and so on. This is called classification. And it's also an apple. We can also divide it into different qualities. This is called grading. Similar to fruits, buildings can also be classified based on their characteristics and graded according to the established standards of the building. So fruits can be graded according to different qualities. What standards can we use for building to grade? Below we will introduce buildings by their nature of use, usually divided into civil buildings, industrial and agricultural buildings. Among civil buildings can be graded based on their durability period, fire resistance, performance, size and importance. Regulations on the design of civil buildings. The durability period of a building determined by its main structure is divided into 4 levels. The durability period of first-class buildings is over 100 years. Is suitable for important buildings and high-rise buildings. The durability period of secondary buildings is 50 to 100 years. Is suitable for general buildings. The durability period of Grade 3 buildings is 25 to 50 years. Is suitable for secondary buildings. The durability period of Grade 4 buildings is less than 15 years. Is suitable for temporary buildings. At the current stage in our country, the main body of urban buildings is generally secondary buildings. There are many external factors that can cause damage to buildings, such as fires, earthquakes, wars, and so on. Fire is the main factor among them. In order to improve the resistance of buildings to fires, in building construction, it is very important to take measures to control the occurrence and spread of fires. According to the regulations of China's building design fire prevention standards, fire resistance rating of buildings is jointly determined by the combustion performance and fire resistance limit of building materials and components. Divide the fire resistance rating of buildings into 4 levels. Level 1 is applicable to important or large-scale buildings. Level 2 and 3 is suitable for high volume of our general buildings. Level 4 is applicable to temporary buildings. Fire resistance limit of building construction. It is the period of time, according to the time temperature standard curve, of the building construction, from the time when it is subjected to the action of fire, to the time when it loses its supporting capacity or its integrity, or loses its fire insulating effect, refers to this period of time, expressed in hours. According combustion performance, building components can be divided into non-combustible materials, difficult to burn materials, and combustible materials. Non-combustible materials. It refers to being exposed to fire or high temperature in the air. Materials that do not ignite slightly, and do not carbonize, such as metal materials used in architecture, and natural or artificial inorganic mineral materials. Difficult to burn material refers to being exposed to fire or high temperature in the air. It is hard to fire, hard to burn, hard to carbonize. After the fire source is removed, burn all microburn materials that immediately stop, such as fire-resistant asphalt concrete. Burning materials refers to being exposed to fire or high temperature in the air, immediate fire or slight ignition, and after the fire source is removed. Materials that continue to burn or micro-burn, like wood and so on. Components made of the same material in architecture, according its function and location. The required fire resistance limit is also different. Buildings with high fire resistance rating, the combustion performance of its components is poor. The fire resistance limit is longer. The above is the method for grading civil buildings. And the grading of buildings is based on its importance and the degree of impact on social life. Typically, important buildings have a long durability period and a high fire resistance rating. This leads to high standards for building components and equipment, difficulty in construction, and high cost. Therefore, it should be based on the actual situation of the building, reasonably determine the durability and fire rating of the building. Now let's talk about the concept of architectural module. Since architectural design units, construction units, construction parts manufacturers are often independent enterprises and may even belong to different industries. In order to coordinate the dimensional relationships between architectural design, construction, and component production, and achieve the goals of simplifying component types, reducing construction costs, ensuring building quality, and improving construction efficiency, China has established unified coordination standards for architectural modules to constrain and coordinate the dimensional relationships of buildings. An architectural module is a selected standard unit of measure, used as a unit of increment in the coordination of dimensions for buildings, building components, building products, and related dimension of equipment. The basic module is the fundamental unit selected for module coordination. Its value is 100 mm, with the symbol M, i.e., 1 million equals 100 mm. It can be divided into horizontal and vertical basic modules. The range of horizontal basic modules is from 1 module to 20 modules. Primarily used for door and window openings, component cross-sections, etc. The range of vertical basic modules is from 1 module to 36 modules. Primarily used for the story height of buildings, door and window openings, component cross-sections, etc. Due to the large difference in scales of various parts in a building that need to be coordinated with modules. On the basis of the basic module, interrelated derived modules have been developed, including enlarged modules and fractional modules. An enlarged module is an integer multiple of the basic module. It can be divided into horizontal enlarged modules and vertical enlarged modules. The basis for horizontal enlarged modules are 3 module, 6 module, 12 module, 15 module, 30 module, 60 module, with corresponding dimensions of 300, 600, 1200, 1500, 3000, 6000 mm. Primarily used for the bay width or column spacing, depth or span of buildings, component dimensions, and door and window openings, etc. The basis for vertical enlarged modules are 3 module and 6 module, i.e., corresponding dimensions of 300 mm and 600 mm. Primarily used for the height and story height of buildings, door and window openings, etc. A fractional module is a value obtained by dividing the basic module by an integer. The basis for fractional modules are 1/10th module, 1/5th module, half of module, with corresponding dimensions of 10, 20, 50 millimeters. Primarily used for gaps, structural joints, component cross-sections, etc. In this lecture, we mainly discuss the classification of buildings and architectural modules. We will introduce them further in future courses. Thank you.